Hey everyone, thank you so much for joining me today. Welcome back to my channel in this new episode of AI Chitchat. And today we are talking with Fernando, who was also one of my
Hey everyone,
thank you so much for joining me today. Welcome back. Again, I'm getting some feedback, but yeah, now it should be fine. He's currently working for Liquid AI, which is one of the most interesting companies in the wave of LLM architectures and deployment. And Liquid is trying to make LLM smaller, faster, and more efficient, right, Fernando?
Yes, exactly. So thanks for having me here.
Yeah. If you want to say a few words about like what excites you, like why large language models and especially small language models, more efficient models, why Liquid AI? If you can talk a little bit about that, and if you can say like what kind of problem are you trying to solve?
Perfect. Yeah. I think all of this started when I fall in love for Elisa. I don't know, like that AI chatbot, very old. I feel like when I was 15 years old, 17 years old, that started to play with all of this stuff. And then I realized that doing something more complex than regular expression matching was very, very complicated. So then I started to play with the BERT models and those very, very old models back then. And after that, when I started to play with T5 models, that was my first wow, like, Jesus Christ, you can train a model that does something that you pre-specify with a prefix, and then you have, which basically the prefix by back then, just for the newcomers here, it was a way of teaching or instructing the models. This is basically the pattern that I have taught you during the training time to do this very specific thing. And I was amazed by that. And finally, I was taken by the storm of Llama and GPT-2, and I was gone deep into all of these things. And here I am doing LLMs, and so I mean, like it was pretty much like getting to the wave that everyone ended up getting into. So I started to do some open source research, co-founded with Eric Hartford, Cognitive Computations Group. Then started to work at RCAI and now finally at Liquid. So I was pretty much like always bullish on small language models and trying to now answer your question, what most excites me in terms of small language models is having the opportunity of running everything on our computer, so considering my past as a professional programmer, as a computer scientist, I was always afraid of relying to something that I hadn't control over, so I was sorry for my Latin, shitty scared about these updates that I very quickly realized that OpenAI was doing over its GPT 3.5 models without any sort of transparency. I didn't know what was happening, so I decided to invest time to see if I was able to get something very narrow, which was important to complete my tasks working on my own computer, so I was pretty much sure which by the next time I was up to run the very same thing with temperature equal to 0, trying to make everything deterministic, I was able to get the very same output that I was getting when I was thinking of this. So long story short, I feel like this is the story of how I end up on small language models,
Yes, small language models. By that you mean something that you can run locally.
Yeah, I define this way. And I feel like the boundary of what is considered a small language model, I would definitely say it's something that fits at least consumer-grade hardware. So if we think of RTX GPU cards, it should be something like it fits on a 4090 or maybe in a 5090, with a decent performance, right? So I do. But this is my very personal opinion that would characterize a small language model. So, for example, by my opinion, 72 billion model is not a small language model. Depending on someone else's opinion, it is.
So this is like I've also been thinking about it, and I've been reading a little bit. So there is no clear definition, like when to call a model small, when to call a model large. It just depends on the hardware that it can run on, right?
I would say yes, and eventually, if we find new ways to compress these models in such a way that, for example, a 200 billion parameter model is suitable for a notebook, for example, then I would be able to call it a small language model, or So I'd say this is pretty much like what it delivers versus the hardware requirements.
Yeah. So, like you mentioned, if the model can run on consumer PCs, like with 4090 or 50 series GPUs, so those are mostly gaming PCs. Like if we talk about like few years ago,
Yeah.
it's not a normal person's computer.
Yeah, that's not the normal personal computer. But on the other hand, seeing all of these evolutions that are happening over MPS, for example, Apple hardware. Now we have actually this is something that I'm willing to bring from the United States. So NVIDIA Spark. This is pretty much like something I'd say accessible for a professional user. So something like around 4K, and you can even run something decently big on that hardware because it has 128 gigabytes of integrated RAM. So I mean, like that's why I feel like this is a nice definition. Instead of focusing how many parameters we have, I'd say small language models is what fits on a consumer device and considering the budget as well, so.
Yeah, sounds good. So, yeah, moving back to Liquid, since your company is also working with small language models at the moment. So, what if you want to talk a little bit about what kind of problem your team is trying to solve? What are you building right now?
Yeah, absolutely. So the very first thing that I feel like it's worthy refreshing everyone's mind is at least up to 2 or I'd say 18 months ago, there was already what we call hybrid architectures, right? So what is a hybrid architectures? Hybrid architectures are basically introduced by Tridal and all of those folks which have invented flash attention and all of these modern inference mechanisms. So they came up with something called Hyena, and the idea was basically you don't need to have over every single layer of large language model or small language model a transformer block. So that was some sort of over use of computational budget. So the idea was how can we replace some of these blocks by what we call convolutional blocks, which are way cheaper, computationally speaking, but still be able to maintain the performance of these models. So that was the breakthrough by then. And what Liquid started to drive at its maximum efficiency was how can we introduce something that we use artificial intelligence to search for an optimized architecture. So this is called neural architecture search. And then by testing on the device that we are willing to optimize for, we came up with a an architecture written from scratch for maximum efficiency. So, and then how could we scale up the amount of training over that theoretical optimizer architecture to have the maximum performance, not just in terms of computation efficiency, but in terms of the quality of the benchmarks, which people end up measuring the quality of these models, and also like doing a lot of testing and etc to be sure that what we are promising is basically what we are actually delivering, you know. So long story though, if I were to summarize, I feel like this is the company mission, you know. So when we think of the challenges that we are overcoming, is now we have this set of different models across different scales, and how we continue scaling up the amount of data that we feed into these models, preserving data quality. So something that I feel like I can disclose a little bit. All I can tell our audience is that data is the king. So instead of focusing so much on the architecture, which we have done in the recent past, now the challenge has been like scaling an immense amount of data and internalizing all of this process without relying on third parties. So our full data pipeline is built by ourselves, so we don't rely on anyone else. But also, like, this is the part of the pre-training, and I'm part of the post-training. So over the pre-training part of the training, as the name suggests, the model just learns how to predict the very next token, right? And the post-training is the team responsible for bringing reasoning capabilities, making actually the model usable, or making the model also being competent on solving very narrow tasks for our customers.
Okay, so so the data quality, obviously, like if the data is good, even simple models are going to give you good results. So that's one thing, but are we also reaching a point where architecture matters more than parameter count?
Yes, then this is actually something very interesting, because what we are outputting over the next, over the past releases and over the next releases as well, is to show off that we can. The core idea of the LFM2 is how can we bring way more knowledge at the very same computational cost of a smaller model, you know. So for example, like having a 350 million model comparable to a 150 million parameter model. So when you have 350 million model, basically you are able to put way more knowledge than in a 150 million parameter model, right? So if I find a way to make it computationally equivalent, all of these two, what I end up having is a Pareto optimal model, right? So I'm able to put more knowledge at the same computational cost. So this is one of the main things of Liquid. And it's interesting to mention that, because depending on the task that we are trying to solve, we should be aware of how can we sometimes compensate that with test and compute. So does that task actually really require some sort of reasoning or not, right? So we try to squeeze the most that we can, trying to solve that without any sort of reasoning trace. And then as of our last resort, then depending on the task that we are trying to solve to our customer, then we try to extend in terms of test and compute. So, and then how does that compare to a larger model? And our main goal, it should be always deliver on very narrow task, GPT-4 or GPT-5 level of performance with something that could be deployed on a CPU, for example, you know.
So you, talking about Liquid, so you are not planning to go into large models with the double-digit number of parameters, or is it planned?
Yes, it is planned, but I wouldn't say like 3 digits. I don't know, but we are definitely thinking of larger models. Our latest one was 8 billion model with 1 billion active parameter. So, but we are definitely going over. At the past, we have already released it of 40 billion MOE. We actually haven't released it because our licensing and our business model was different in terms of what we are doing. And this comes to the point which I feel like this is also very interesting for our audience, which is our toolkit called Leap. So the idea of what Liquid is pursuing is basically creating also stuff that people can fine tune locally and focus on device intelligence. So, for example, this is at least my very personal perspective. I'm a lot skeptical about artificial general intelligence. I feel like we are not close. And we should be focusing on actually solving, very, very narrow tasks which have a high value being added to the people,
So
the idea of this toolkit.
Yeah, I also have a question from the audience, and my next question was going to be quite similar. So, are people think like small language models are not smart enough? And the question that I have is it possible that we can build a conversational bot on small LLM? And they want to say like if they are capable on to be on some level to be good conversational partners. And to add to that question from my side, can I use small language models to build me AI girlfriend that works?
Well, I feel like yes, people would be very capable. However, this is something that was one of my first projects when I was working actually way back then with Eric Hartford. And it was a kind of a fever over the open source community, which was what we called back then by Franken Merge. So, and Charles Goddard, our former colleague from RC as well, was one of the people that were working with it. So the main idea of having a very strong small language model with conversational capabilities is depth is the king. So it seems like bringing a lot of conversational capabilities in terms of creativity, in terms of mimicking something closer to the human behavior, etc., was pretty much like a function of the depth. So the very first exercise that we've made back then was trying to stretch a Llama 2 model, which was 70 billion model, to something like 120 billion, and then which was called Mega Dolphin. And if you go over Hugging Face, there are lots of role-playing models built on that framework with a 120 billion parameter. So, but the model, I feel like this is very important to notice. But the model wasn't smart, I mean, like the model was smart, but not intelligent. So, when you stretch the model, what we have realized was the model was pretty much like reasoning or behaving more like a human, but also it ended up losing its knowledge. So I would say like this is the difference between being smart and intelligent, right? And going back to the question that the audience made, there are some models which are very deep but very thin, So they're not wide in terms of their hidden dimensions across the layers. So there is a very interesting example, which I feel like it's a delightful model to be playing with. Falco H1 Deep, made by the folks of UAE. So this is a very neat example of something very good for conversation, and very, very small. It's a 1.7, something like 1.6 billion model, which is very deep. If I'm not wrong, it's about 66 layers. Usually a model of that size is 36, 32, depending, 28 layers. All right. So the model is very, very deep, and it's not that much wide. So if you do a lot of DPO, etc., 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 very likely you're going to end up having a very pleasant model to be talking with. You know.
Yeah, I think it's a good try. I've tried
Yeah,
fine tuning small models, and I'm sorry.
And it's very easy to.
Yeah, it's very easy to train. Yeah. That's why, like when I was working with Hakim Face, we built this fine tuning. So did a lot of fine tuning for, many billion parameter models, small models. Yeah, it works quite well.
Yes.
So, like, okay, changing the topic a little bit and coming to model training. So, what do you think about efficiency in training, like both in compute and data? And what do you think? What are like some of the techniques that you could talk about, which make training more efficient, like better optimizers, or is it like data selection, efficient or efficient architectures?
Yeah, well, I feel like everything is heavily dependent. In terms of the optimizers, I feel like they're heavily dependent on their architecture you're playing with. So, for example, like I feel like this is something that I can disclose because for our architecture, this seems to not work. So, Mune, which everyone has been talking about, for LFMs, they seem to underperform Adam, you know. So, and it seems like there is a lot of evidence everywhere that they overperform Adam across different architectures. But in ours, at least by the few experimentations that I've made, and I feel like some of my colleagues have done as well, it doesn't. So the very first thing is, without disclosing too much confidential information from my work, it's a lot of empirical evidence, and also trying, because it's very hard to find one fits all solution in terms of optimization. But there are other stuff like are very helpful, you know, like if you're willing to save a lot of compute. So, for example, something like which we have open sourced was Spectrum before I joined ours, and this was actually the main reason why me and Lucas Atkins were hired by ARC. It was because of Spectrum. So, for example, Spectrum is a technique which you can selectively freeze layers with some special features that the algorithm helps us identifying without going too deep into the technical details. So, for example, like if you freeze 75% of your layers, you're going to have a very competitive performance against the original or full fine-tuning training, but saving like 3 times the amount of compute, especially or actually memory, especially if you're in a distributed setting, you know. So this is something worth it trying for the sake of reinforcement learning, fine-tune. There is this beautiful blog post from Thinking Machine Labs, which I feel like it's a very decent guidelines for LoRa adapters as well. So, for example, like for the sake of reinforcement learning, LoRa seems very helpful, and it makes actual sense because of the nature of the gradients on reinforcement learning. But for example, like on full fine tuning, LoRa is quite tricky, because there is no clear evidence in terms of what is the trade-off between what you learn, what your data size. There are some evidence which, and this was one of the points of Spectrum as well. In LoRa, you forget less, but you learn less. So I'm more like a believer of this church, if I were to say. So in terms of this thing, I would point that out. But I mean, like, if you save a lot of compute on one part, you end up having to search for other sort of optimal hyperparameters. So something that should be very clear is, are you trying to fine tune everything on your device, or if you're renting a specific infrastructure with and you're trying to speed up the training because it's going to cost less over time, so you're going to save compute in the time dimension, or if you're willing to save memory, because also there is a trade-off of having a card like a 1490, which has a decent amount of CUDA cores, right? But on the other hand, it lacks the memory, So if you find a way to set up a training which you're going to save a lot of memory, then you can enjoy the benefits of having a lot of CUDA cores, especially on 1590, for example. So I don't know
yeah, sure. Like, so the lot of different things to think about when you're fine tuning the model. What about like when we are talking about pre-training?
Pre-training is a completely different beast.
Yeah, that's why I'm asking.
It's
very interested to learn.
But basically, it's all about actually being able to understand huge workloads being distributed across a huge amount of nodes, having a strong multi-node setting, also being able to recover your training from faulty nodes, because eventually, for example, one of your nodes will have illegal access to the memory, and that node might collapse. And then how you end up trying to minimize the disturbances and perturbations overall. So this is something that, to be very fair with the audience, I'm not an expert at. I've been always the person which was pretty much like crossing the fingers, cheering up for everything go fine, and just providing some inputs regarding the architecture details, because I feel like when you use it to post training, there is some stuff that you end up realizing very quickly, because who pre-trains the model, right? They end up doing runs for very long horizons. Sometimes like a pre-training lasts for weeks, so there is a lot of babysitting, so there is the overlap, which I could say, between post-training and pre-training is, at least from my very personal perspective, as of being able to, I have the privilege to fine-tune a lot of different models across different architectures, especially when I was working at RCN Cognitive Computation. I feel like we've been able to provide meaningful insights for the people which are thinking of pre-training, But I mean, like, there are different animals. These guys are genius. Just the skills are also very, very different. And there is the middle ground, which we try to to converge the ideas, right? So, for example, like, oh, that, for example, should be something that might be helpful for us for downstream tasks, right? But on the other hand, for a pre-training person, these folks actually have on their mind how easy that's going to be able to train. They are also very strong at thinking of the latency of these models, So we try to find a balance of what we think that could be good when we think of post-training, and how easy is that, how fast is that. These are the skills which are very, very precious skills, for example, which I don't have, So scaling all of this infrastructure is basically a hell, So.
Sure. So, like, one of the questions from the audience is around SLMs and distilled version of large language models. So, what will you say, like, the basic differences there are? I think that's just the, like, SLMs are also foundational models, right?
Yes. All of them are foundational models, right? I would say, so if we could go back over the question, the person is also willing to understand distillation.
The difference, like, what would be the difference between a small language model and the distilled version of large language model? I mean, distilled version.
No, I mean, like,
it won't be a foundation model.
Distillation. Yeah, I mean, like, doing distillation is basically a transfer learning technique of one foundational model, which is usually larger, to another foundational model, which is smaller.
Yeah.
So,
but like,
I feel like this is the very
SLM LLMs are both trained from scratch.
Are both from the Yes, exactly. You can't distill basically something with towards a model that doesn't have any sort of internal knowledge pre-existing, right? So this is something that should be straightforward, clear for everyone. And out of curiosity, I had the pleasure to open source the first distillation kit when I was back then at RC with Lucas Atkins. It's called DistillKit, as the name suggests. And I feel like there are very interesting, cool stuff that we can do with that. So, for example, like, especially when you have reasoning traces. So, first, just outputting a lot of tokens and saving those trajectories and teaching a model by doing SFT, I would say that's a kind of naive distillation. But why is that a kind of naive distillation? Because distillation goes beyond of just trying to imitate the teacher. So depending on how close we are able to imitate the teacher, better are the results that we are going to get from our distillation. So for the main idea of DistillKit was twofold, right? When two models share the same tokenizer, it would be way richer thinking of transfer, the probabilities associated with each token over the large language model had to the small language model. So instead of just imitating, replicating the very same tokens, which is basically what we end up teaching when we are teaching a model by doing cross-entropy loss, we add another loss, which is a function of the KL divergence. So KL divergence, in layman terms, is basically a way to put into a single number how can we compare two different distributions, right? So when we think of the distributions across the tokens, a model can sample a specific token or another token with different probabilities, and this is the function why we end up choosing the temperature, right? So when we increase the temperature, we are broadening the choices that the model are going to be able to do in terms of outputting new tokens. And this is actually the thing that we are trying to make the small language model to imitate the larger language model, because when we sample the single trajectory, it's a function of every single token that was sampled at a very specific thing, which was pretty much like a function of the luck or the probabilities observed at very specific trajectory. But what we are trying to learn is a policy which is broader, So what we are trying to make this model is actually reason as the larger one, right? So there is this kind of technique, and there is another kind of technique which is called hidden state matching. By the way, Google has just released Distillation open source kit as well, which cloned ours, which we were glad. And the main idea was when the tokenizers are different, how can we think of transfer the knowledge across the models? And this other way is basically trying to match the learned representation between the layers or the self-attention blocks between two different models. So instead of observing the tokens right in the output, we try to do something like a PET scan of the model, a CT scan of the model, in such a way that we are able to see what is happening within the model and transfer those events to the target model. So
Yeah.
and this is how
I think that would be topic for another AI Chitchat video. But so now for the audience, we are approaching the end. So if you have any questions, please feel free to ask. I've skipped some questions, so I'll take them in some time. Okay, so yeah, coming back to small language models. I forgot my flow. So do you think like there's still when we are building AI agents and they're working on device, so do you think there's still like a major gap between the reinforcement learning research that's happening and the real world deployment?
Well, that's a very tricky question.
Yeah.
Just because it ends up involving a bit of confidential information, but I feel like
no, you don't have to like, yeah, it can be your views.
Yeah, absolutely.
Yeah.
But I mean, like, it's very hard to separate when you get into this very specific topic, and to be fair, this is one of my main topics internally at Liquid, right? So it's a little bit hard to draw a line of.
Then it's bingo for me.
Yeah, exactly. So what I'm pretty much feel confident about sharing, which is basically what the whole open source community has been witnessing, is in terms of small language models, when models have been the kings up to then, but we are changing this scenario. So if someone tries to do RLFT over liquid foundation models, people are going to get very excited and surprised. So we are basically kind of destroying this absolute kingdom of quant models, And what we have realized so far, one of the main reasons why quant have been so successful, and I feel like there is a beautiful paper from the Octo Thinker team folks, which was basically mid-training is one of the most important parts to enable reinforcement learning fine-tune, right? Because you're just going to be able to I'd say like slip away a little bit, drift away from your internal knowledge only if your internal knowledge is very broad. So I mean, like, if you keep up pushing very close to the boundary of what the model already knows, this is the way to go. I mean, like, you're not going to get anything meaningful by trying to do reinforcement learning from something so off policy. So this is basically a wide consensus from the open source community, and now, without revealing our internal recipes, this is one of the major points that we have been working so hard internally at Liquid to close this gap. So if you try to do something besides Quen models, very likely, and fortunately now Liquid Foundation models, for example, if you try to do any kind of reinforcement learning of a llama model with a very small model, you're not going to be successful. They're very, very dependent on the formatting, and if something is a little bit out of their distribution, you're not going to get anywhere. So having that said, and trying to summarize all of this, because I feel like this question I'm taking too long to answer. For very narrow tasks, I feel like this is very, very promising. The thing is, if you try to do a lot of reinforcement learning, having any sort of generic agentic small language model, very likely, my 2 cents, and now this is my very personal perspective, you're going to fail. However, considering that on-device has very specific needs, and those needs are, I feel like they're naturally aligned with what these models are able to do. So, for example, having a strong deep research model, is it going to be powerful as the GPT-5 deep research? No. However, if you're on a cell phone, if you're on a tablet, or even your laptop with an internet connection, and you're willing to decently have some sort of deep knowledge about a certain topic, this is something that a small language model can actually do. Or having something like an Alexa that actually works. This is also something that we are going to be able to do. And today we have actually announced it at Roscon, a partnership. When I think, if I'm not wrong, I have shared the post as well. For example, like a VLM, a robotic agentic small language model operating on device, providing insights for what are the next actions should be for the robot. So this is another use case. So I mean, like, you're not going to have a GPT-5 or a Claude Sonnet, but to skim over GitHub repo, deep research, organizing our tasks, etc., etc. I feel like they're pretty much decent and capable if you do the right thing, or SQL.
Yeah, so I think we are almost towards the end, so maybe a couple of more questions. We have already talked about all this, but in the next 3 to 4 years, where do you think the AI architectures are heading? Is it more edge capabilities, more specialization, autonomy?
I'm pretty much bullish on on-device AI. So, for example, we must find ways to operate decentralized, disconnect, offline, and this is where we have been investing so hard, and was one of the main reasons why I've joined Liquid, because I feel like this actually is something that makes sense. AGI is not there, in my personal opinion. Hopefully I'm wrong, because I would love to have a AGI or any sort of super intelligence, but don't think we are going to get there over the next 3 years, 4 years. Also, I'd say on-device and agentic AI. And for the sake of agentic AI, I feel like, yes, we are going to need to scale up a lot of compute for reinforcement learning, to make all of these models become even more proficient, to play with the environments and perform actions on behalf of the people, so I feel like these are the main things to explore over the next few years.
Yeah, okay. So this is like an imaginary question that just came into my head. So let's say you have on-device language model and with some agentic capabilities. So what kind of task would you want it to solve for you to, let's say, so that you say like, okay, this is nice, awesome. So what kind of task is in your mind? I'm not talking about evaluation, general evaluation, but
yeah, absolutely. Yeah. I feel like having some sort of Alexa that works, like Siri is stupid, Alexa is terrible, I mean, like, with all due respect with Amazon, with Apple, I feel like they're brilliant companies. They have contributed a lot for AI, for computing, but I mean, like, the products are not there, the most complex and thing that I end up doing with Alexa is setting up a timer when I'm helping my wife at the kitchen and asking what time is it, and actually also asking to play a specific song on Spotify. These are the three basic things that I'm able to accomplish with Alexa. I would be delighted to go over my emails. I would be delighted to manage my schedule, to move meetings, to set up a meeting with a Zoom call. I mean, like, doing more complex stuff as if it was my secretary, So this is something, and also being able to do research, So something that frustrates me a lot is, but I still try to use from Alexa is when I'm doing something else, I ask a very specific, narrow question, hopefully to see if Alexa comes up with an interesting answer coming from Wikipedia, which is like something that should be quite simple. But still, Alexa struggles with that, So if we are able to do this kind of stuff with our cell phones, together with this very basic other stuff like writing a draft for my email, helping me skimming a document, summarizing stuff. I mean, like, this is the day-to-day use, which is very useful for people, exploring AI. Helping my kids with his homework is also something that I would be delighted,
Yeah, yeah. I think it's so too. Like, I don't use Alexa, but yeah, hopefully things can improve on an iPhone or an Android phone, and local LLMs. They also ensure privacy since it's running locally.
It's actually something very important. So yeah, absolutely. And by the way, before finishing, I would love to invite everyone. Tomorrow we are going to have an Ask Me Anything session from Liquid AI over our Discord channel. So I'll be there with the full team there. So the questions that I wasn't able to answer, like about the pre-training, visual language models, etc., every single member of different teams are going to be there, our audio models, so there will be Jim Smith, which is the brilliant guy, which is the person in charge of our pre-training. Maxime Lebon, who is going to be there, I'll be there. So lots of interesting people there. So
I think we touched everything, but yeah, do join the AMA tomorrow. What time is it? Oh, I can share.
It's going to be if you could share, but it's going to be 24 hours.
So yeah, it's a 24-hour Discord thing. Okay, yeah, I'll share the link to the Discord and also Fernando's socials in the pinned comment right after the video. And you can also watch this video since it's going to be recorded. You can also watch it later. I'm sorry, it seems like I have missed a few questions from the audience today. I'm really sorry about that, but I didn't want to interrupt when Fernando was talking, and I got to learn a lot today. I hope everyone else did too. And thank you so much, Fernando. This has been really fascinating deep dive, and thanks for sharing your perspective, what you do, and yeah. have a nice rest of the day.
Thank you. Thank you.
Thank you everyone for joining, and do like, subscribe, share, the usual things that I always say. Yeah, and see you in the next AI Chitchat video.